Now look on DAC. Okay, DAC stands for digital to analog converter. The function of DAC is to convert digital codes into an analog signal, which can be current or voltage. In terms of computer-based control system, signal in digital form is very handy to be transmitted. However, digital coded signal need to be translated or converted so that it is easier for human to interpret the information carried by the signal. This conversion operation is done by DAC. Similar to ADC, the range of the signal for DAC is divided into 5 range, which is underflow, underrange, rated range, overrange, and overflow. Take a look at the current column, okay, this column. For output range between 4 to 20 milliamp, which is this one, okay. Current column for output range 4 to 20 milliamp. The decimal unit for 4 to 20 milliamp is between 0 to 27,648. Okay, you have to look on this column, 4 to 20 milliamp column, and we are only interested on 4 to 20 milliamp. Okay, and this is the decimal unit. This is the decimal unit for 4 to 20 milliamp. Again, for PLC programming point of view, we are more interested on the rated range only. Analog output can also be configured in symmetrical and asymmetrical manner. For symmetrical, the decimal unit is always minus 27,648 to plus 27,648. So this range will be converted into plus minus 10 volt or plus minus 20 milliamp. Meanwhile, for a symmetrical point of view, the decimal unit will be in between range 0 to 27,648. And this range will be converted into either 0 to 10 volt or 1 to 5 volt or 0 to 20 milliamp or lastly 4 to 20 milliamp, which is most of our interest and most of the industrial application is using 4 to 20 milliamp signal. Look at example 1. So we have convert raw analog input signal as digital count between 0 to 4095 to engineering units, which is required by test cell operator to monitor the temperature. An oven has a range of temperature between 50 to 400 degree Fahrenheit. The oven temperature is measured using a 12-bit resolution analog input module. This temperature sensor is measuring this oven temperature. Assuming that the measurement is in range between 50 degree Fahrenheit to 400 degree Fahrenheit. This temperature sensor, which is also coupled with a transducer to make up a temperature transmitter, is connected to a 12-bit analog input module. Signal conversion in this analog input module is correspond to a decimal unit between value of 0 to 4095 decimal unit, and this analog input module is connected to the operator workstation in order to display the oven temperature. We're going to look how can we construct a relationship between the temperature transmitter, which is analog input signal, and the decimal number, which is in decimal unit. We're also going to look on the ladder diagram implementation for S7 300 family and S7 1200 PLC family. We start with investigating the decimal unit relationship with the oven temperature. So the decimal number is in between a 0 to 4095. This is the decimal unit sent by the analog input module. And on the operator workstation, the display have to be in between 50 degree Fahrenheit to 400 degree Fahrenheit, and the oven temperature must be between this number, between this decimal unit. For example, it can be 10 decimal unit, it can be 200, it can be 1530, it can be 3020, and so on. So we're going to see how can we create the relationship between if this value correspond to what temperature in degree Fahrenheit. Mathematically, we can interpolate that relation is such that the maximum analog input, the value of the analog input minus by 0, and the maximum value of analog input minus by 0. Okay, and this ratio must be similar to on the temperature ratio. So temperature in degree Fahrenheit minus 50, temperature in degree Fahrenheit minus 50 degree Fahrenheit, and the maximum oven temperature, which is 400 degree Fahrenheit minus 50 degree Fahrenheit. 400 degree Fahrenheit minus 50 degree Fahrenheit. And we are interested on this unknown. Okay, we are looking, this is the unknown. So rearrange everything. So what we get is the unknown, which is temperature in degree Fahrenheit, is equal to analog input over 4095 times 350 degree Fahrenheit, whereby these come from 400 degree Fahrenheit minus 50 degree Fahrenheit, which come from this one. Okay, plus 50 degree Fahrenheit, which is this one. So this one comes from here.